All right, we're looking at the answers to the area volume test review. Number one, the graph shows y equals 1 half x and y equals the square root of x, and regions R1, R2, and R3 contained by those graphs, and line 1 and line 2. Find the area of R1. So R1 is right here. We need to find the area. So the first thing we want to do is figure out where we start and where our interval stops. So we set our two functions equal to each other. 1 half x equals x squared. I squared both sides, so 1 half squared gives me 1/4. X squared gives me x squared. The square root of x squared gives me x. I multiplied both sides by 4 to get rid of my fraction. I moved the 4x over, and then I factored out an x, and we see that our intersection points are 0 and 4. So that's why I have this marked as 4. I'm also going to need to know the height of this thing. So if I plug 4 back into either one of these equations, I'm going to figure out how tall it is. So the square root of 4 gives me 2, and 1 half times 4 also gives me 2. So that's how I know it's the height of it's 2, and the right of it is 4. So the area of R1 is right here. So I just do top minus bottom. So the top is the line 2, and the bottom is the square root. So that's why I have 2 minus the square root of x dx. And on this review, I'm just going to show you how to set it up. Everything else you should be good with. The setting it up is probably where if you have questions, that's where you have a question. So I'm just going to show you how to set all these up. Next one, we want the area of R2. R2 is right here in the middle. So I need top minus bottom again. The top is the square root. The bottom is 1 half x. So that's why I have the square root of x minus 1 half x dx. We're integrating from 0 to 4, from 0 to 4, which is right here. The next one, find the area of R3. We've got to use calculus. I say use calculus because this is a triangle and you could figure it out without calculus, but we want to use calculus. So I want the area of R3. So again, I do top minus bottom. Top is 1 half x, bottom is 0. So we're going to go 1 half x minus 0. We're integrating from 0 to 4. So there's number one. Number two, we're doing rotations on number 2. On A and B, we're doing it without a calculator. On everything else, we're doing it with a calculator. So R1 around the x-axis. So rotations, remember, we're always going to use A equals pi r squared. So we're doing R1 around the x-axis. So R1 around the x-axis. So whenever we're rotating, we want to know, is there a gap when I rotate? In this case, R1 is right here. There's a big old gap in there, so that means I've got to have 2 R's. And so as you see, I've got 2 R's. And also what we're rotating around has to be a part of both R's. What I'm rotating around is the x-axis. It's on the bottom, so that means it has to come second. So my first R is going to be top minus bottom, which is 2 minus 0. My second one is going to be the other part, which is the square root of x minus 0. So R1 is 2 minus 0. R2 is the square root of x minus 0. So I have R1 squared minus R2 squared. I've got the pi out front. We're integrating from 0 to 4. And then you just work it out from there. Next one is R3 around the y-axis. And I noticed that I did that wrong. I was assuming the x-axis. So I'll come back to that. Ignore this right here. It's totally wrong. I'll come back to it later. Part C, R3 around line 1. R3 around line 1. So here's R3. We're going around line 1. Notice when I rotate this thing around, there is a gap. So that means I need 2 R's. Line 1 is on top. So that means 2 is going to come first on both of them. So notice 2 is going to come first on both of them. So what are we rotating around? Or what's our region? R3. So R3 is right here. So we're going to go 2 minus 0 for the first one, and we're going to go 2 minus 1 half x for the second one. So 2 minus 0, 2 minus 1 half x. So R1 squared minus R2 squared. Got the pi out front, punching in my calculator. The calculator I used gave me 33.510. I did not bring my calculator home, so I had to go off of a calculator on the internet. So hopefully that calculator gave me the correct answer. All right, part D, R2 around y equals -1. R2 around y equals -1, which is going to be down here. -1 is on the bottom, so that means it's going to come second on both of them. And again, I've got a gap when I'm rotating, so I need two r's. So top minus bottom. So top is the square root of x minus a -1. And then bottom would be 1/2 x minus a -1. So square root x minus a -1, 1/2 x minus a -1. I've got r1 squared. I've got r2 squared. I've got my pi out front. I'm integrating from 0 to 4. My calculator gave me 16.755. E, I need to do r1 around line 1. R1 around line 1. This time, notice when I'm rotating, there is no gap. There is no gap, so that means I only need one radius. So that's just going to be top minus bottom. So that's going to be 2 minus the square root of x. And I have 2 minus the square root of x for r, so I have pi 0 to 4, 2 minus the square root of x squared. My calculator gave me 8.377. F, R2 around line 2. So R2 around line 2. Okay, notice I'm going around something vertical, so that means I need to solve for x. And that's what I did over here. I took this equation and solved for x, and I got 2y. I took this equation and solved for x, and I got y squared. So R2 around line 2. Line 2, notice line 2 is on the right. R2 around line 2, so when I'm rotating around this thing, I do have a gap, so that means I need two r's. Line 2 is on the right, so that means 4 is going to come first on both of them. So 4 minus the square root. The square root turned into y squared, so I have 4 minus y squared. And then I have 4 minus the line, which is 1/2 x. The 1/2 x turned into 2y, so I get 4 minus 2y. So also notice my limits change. We got to use our y limits. Our y limits are 0 to 2. So R1 is 4 minus y squared. I've got that squared. R2 is 4 minus 2y. I've got that squared. I punched this in my calculator. My calculator I used that gave me 20.106. All right. Next one. This time we're doing slices on the last page. And we're doing it with R2. So semicircles, my area formula is 1/2 pi r squared. So I need to figure out what r is. R is going to be top minus bottom. So square root minus the 1/2 x. So square root minus the 1/2 x. And remember, since I'm doing semicircles, I always have to divide the r by 2. I plug that in. So I have my r squared. I have the 1/2 pi out front. I've got my limits. Calculator I used gave me 0.209. Next one, equilaterals. I'm doing equilateral triangles. If you look it up, the area formula for an equilateral triangle is square root of 3 over 4 times a squared. So a is just going to be top minus bottom. So square root x minus 1/2 x. I've got the square root of 3 over 4 in here. I've got my a squared here. Plug it into my calculator, 0.230. And the last one, this one we're doing without a calculator. We're doing it perpendicular to the y-axis, so that means I've got to solve for x again. And this time our cross sections are squared. So our squares. Our area formula for a square is side squared. A side is going to be right minus left. So right minus left. So that's going to be the line minus the square root. And right here, so the line we turned into 2y, the square root we turned into y squared. So 2y minus y squared is what I should see for s, which is what I have, 2y minus y squared. I plug that in. I've got to square it. Remember, we've got to use our y limits again. First thing I did was multiply this out. So I multiplied that out, and then I integrated. When I worked it out, I got 16 over 15. So there are your answers to the area volume test review. And again, remember that number 2, part B, I did it incorrectly. I need to go back and redo that one, and I will let you know when I do. All righty.